So we've taken a look at how we can draw out quadratics based on a table of values. Now we're going to take a look at what is a quadratic, and we're going to describe a little bit of what a quadratic is. So the first thing that we say is that a quadratic, and I'm just going to fill in some blanks here, has a U shape, and we're going to use the word parabola to describe that, which continues to expand outward, okay, as the x value increases and decreases. So you'll notice this here, this is a computer printout one. This is from Desmos. Okay, it continues outward. Now it doesn't continue outward at the same rate. It kind of gets narrower as it goes, but it never actually gets straight up and down. It keeps going outward, but not as much as it continues to go upward. Now, as we saw with our previous examples there, a parabola can either open upward or downward. Okay? And we're going to discuss the reason for this a little bit later on, but you'll notice this one here opens upward, and the previous example that we had here opened down. Okay, so we're going to discuss how that works and why it works a little bit later, but we'll get to that in just a little bit. Now, how can we describe and graph these out? So when we graph out a quadratic, each of the following pieces of information must be shown in our quadratic, and some will already be, and some we might have to draw in there. The first thing that we're going to always put in is something called the vertex. Okay. Now the vertex is either the bottom or the top of the parabola. Okay. This is a point which can be referred to as either a maximum or a minimum, okay, of the quadratic. And in this case here, right here, that is going to be our vertex. Okay, the point 20 is our vertex. I've put that in there using Desmos just by clicking on the point. Now, that is our vertex. That is, in fact, a minimum in this case here because it's the bottom, so it's our minimum value. We'll talk a little more about minimums a little later on, but that is a minimum value. That is our vertex. Okay, just get the right color here. All right, so the y value at our vertex is going to be our max or min. So the y value is 0, so we're going to have a minimum of 0. Again, we'll get into that in a little bit. The next thing that we always want to make sure that we label is our y-intercept. Okay, if feasible, you'll notice right here it's already labeled. It's 0, 4, so this is our y-intercept. You don't have to write y-intercept, but you must have what the point is. So if it is possible to do it, sometimes it won't be, sometimes it will be, you must have it labeled as to what the point is. Okay, so our y-intercept in this case is 0, 4. Okay, so our y-intercept is 4. Now this is the point where the quadratic crosses over the y-axis. This should be understandable from previous graphing experience as to what that is. The second one, or the next one there, you might be able to guess already what that is. That is our x-intercept. Okay, we also call the roots and zeros. Okay, so those are two different things that we call the x-intercepts. So we might have, we might call them roots or zeros. This is where the quadratic crosses the x-axis. Okay, and a quadratic can either have 2, 1, or 0 roots. Okay, 2, 1, or 0 roots, and we'll go through again a couple examples of that. This one right here just has 1. It only has one spot where it touches the x-axis. Okay, it touches it and then goes back up. This one right here has 2. It has 2 spots where it crosses the x-axis. Those as well must always be labeled. Okay, so that's the x-intercept. In this case, we just have the 1. We can also call these zeros, okay, roots or zeros, as the points are where our dependent variable is 0. So our y value is 0, and thus our x value is our 0. So our 0 would be 2 in this case, because 2 is our x value at that intercept. Now the final thing on this page here that we're going to look at is something called the axis of symmetry. Okay, each quadratic is symmetrical, okay, around the axis, and this means that it is exactly the same on the left hand side as it is on the right hand side, and I'll show you that in just a little bit. So the axis of symmetry runs through the vertex, and it is a vertical line that goes through the vertex. The left and right hand sides of the quadratic are identical. Okay, and we can use this later when we want to find matching points. Okay, I'm just going to give you a little bit of an example of that here. This right here is our axis of symmetry. It is a vertical line which goes through the vertex. So this is our axis of symmetry. Okay, and it has a value of x equals 2. So it's exactly what we have here. That 2 right there is how we would label our axis of symmetry. That must be labeled as we go through. You notice that everything on one side is equal, the same as the other. If we go 2 spots to this side, we get 4. If we go 2 spots to this side, we have a 4. Okay, the y value is 4, y value is 4. Okay, so from the two places over would be 0, so 0, 4. 2 places over would be 4, 4, 4. So it's symmetrical. It's exactly the same on both sides. Now I'm going to just go through a couple things really quickly on the next page, so this video doesn't get too long. A few other things that we must draw in are arrowheads. So if the quadratic continues outside of the drawn graph, arrowheads must be added. You'll notice that we have the arrowheads on here. Those are very important. I'm just going to quickly put in, this is our axis of symmetry right here again. I always draw it in as a dashed line. Okay, so this is x equals 1 in this case. This is our axis of symmetry. Okay, I'm not going to label everything else as there is. We went through that in the previous one. The x and y axis, we must label what they are. In this case, it's just x and y. That's all it is. Once we, and should put arrows on those as well. Okay, once we get to contextual problems, then our x and our y are going to have something else, but that is when we get to like word problems and when they actually have some sort of context to them and they're not just x and y. Okay, again, it's important when we have the context. The equation, okay, so we must have the equation in there as well. This one here, I don't have the exact equation. Yeah, I didn't put it actually in there. So we would normally put the equation in there as well as to what it is, and then we would always put the domain and range, and we'll talk about domain and range in a little bit. Remember when we went through linear inequalities, we talked about domain and range. Okay, we're going to talk about domain and range again. So we must have the equation in here on the graph, as well as our domain and our range. Those things always need to be in our graph, and they need to be describing what our graph has. So that's what we think, those things that we need to have in our graph. Every time that you have a quadratic question, I'm going to be asking you to draw out a graph. It does not have to be magical and amazing. It can be very simple. You can use Desmos to come up with most of those graphs, and we'll go through that again in a little bit. But it must be drawn out on paper. Make sure you have your axis, make sure you have your quadratic, and make sure you have all your points labeled, okay, as nicely and neatly as you can.